Hello and welcome to this Mobile World Live webinar exploring the economics of non-terrestrial 5G. I'm Michael Carroll, the Senior Editor with the publication, and I'm delighted to moderate this discussion. 5G NTN is a hot topic at the moment, and I'm sure you'll have plenty of questions, so do please put these in the box under the main presentation, and we'll do our best to cover those later. In a moment, Chris Jenkins and Suman Chandra Sharma from Mavenir, along with Jacques Leduc of Terrestar Solutions, will offer their insights into 5G NTN technology and the overall business case. But first, let me hand over to GSMA Intelligence analyst Tim Hatt to set the scene about the market today. Take it away, Tim.
Thank you very much, Michael, and great to be here. So as Michael said, this is a really hot topic right now, and has been really for a couple of years. What I wanted to do was bring in some of our analysis and recent data to sort of set the table for what is driving this telco satellite convergence momentum, as well as what we think that means in terms of coverage extension and monetization possibility in different segments. And then we will hand over to our other speakers and I'm sure have a great Q&A. So I think it's important to sort of set the context by showing the capacity gains that we're seeing from non-terrestrial networks, and how that compares to the sort of historical evolution the last 10, 15 years. And this chart here shows that you have this sort of LEO low Earth orbit driven volume gain. And because of the constellations coming online, that's really going to have an effect on the cost structure of satellite delivery. And it helps really the go-to-market speed for which telco and satellite partnerships can take place. So really this is a total change in what we've had in the past, and it sets the underpinning for a lot of the service innovation that we're going to be talking about. When we look at the what's driving the momentum, I think one of the key indicators for us when we look at that is, how many operators are, mobile operators are partnering with satellite companies, and where does that, take place around the world. This is from our recent NTN tracker. And you can see there's 2 points I think I would make on this slide. One is that this is not a regionally specific trend, it's a global trend. Right now we have, in fact, just around 65% of global market share, operators representing that share that have an active satellite partnership in place. That's close to 100 now. That's doubled in the last 12 months. So that's a very sort of clear indicator of the momentum. The second point is that you see this broad-based demand for extending networks from terrestrial infrastructure to uncovered areas in all regions. Asia Pacific has the most number of operators, as you can see, by virtue of its population. But actually, as a share of the networks in use, we see a broadly consistent trend across all regions. And I think that speaks to a lot of the opportunities in monetizing the consumer, as well as the B2B and IoT and government segments. So this is a broad-based trend. This is a graphical view, a kind of map-based view to show breaking down those partnerships between telecom operators and satellite companies, the stage of maturity that they are at. And the different colors correspond to those. And again, 2 points to make. One, you see the geographic spread of the coverage pattern. Two, you see actually in a number of areas, we're still at the point where the partnerships have been formed and services are in testing and pilot phase, that kind of dark blue shade. But as we go into 2025, and that's sort of the reason for the title of this presentation, Look Out in 2025, a lot of these will start to move into live commercial service offerings. This will probably take place in a phased transition. A lot of the partnerships we see now involve partial service, 2 or 3 hours a day, for example. But as those capacity upgrades and augmentations happen, that's going to extend out to probably a lot more continuous service service offerings from 2026 and beyond. So there is the momentum, and we think that plays out over a sort of 2 to 3 year period into the marketplace. One of the interesting, I think, indicators and signs of the technology innovation is the direct-to-cell or direct-to-device story. Starlink is one of the pioneers in this area, but not the only one. We see a lot of activity from other companies, Link, AST, and others beyond that, pursuing this model. And that matters because it offers a satellite kind of paradigm shift where service is delivered direct to a device, be that a handset or other IoT module, for example, without requiring a receiving dish or intermediary equipment that previously had to be used. And what we wanted to do with this table is sort of give a quantification of that and how that splits out among some of the different satellite players. And you can see there on that kind of, with this hashed square on the right, for a number of these players, direct to cellular services is like half of the partnerships or more that they're involved with. And I think for the telecom sector, that's important because it brings connectivity, to a more frictionless model for customers and businesses that want this type of service. That's something we're going to follow closely because now that the end-to-end standards have been enshrined in 3GPP through Release 17, Release 18, that really presents an order of magnitude increase in the addressable base for which this service can be sold into. And so the next step is really how that translates into the OEM and device maker product roadmap and portfolio roadmap. That's a commercial decision. Some will move quick, some will move slower. But I think through the recent news, Apple and Globalstar, we're seeing it in other device makers that this is developing as a competitive USP. Just quickly to delve into briefly the consumer and then secondly the business monetization strategies here. So the consumer strategy for extending satellite is really based on two things. One is bringing people into coverage who don't already have it. Second is monetizing through roaming. This chart actually shows the first of those, and it really is making the point that whilst we take for granted network coverage, mobile broadband coverage, which is a 4G network or a higher speed, so 4G or 5G, we take that for granted at ubiquitous levels in North America, Northeast Asia, Europe. That is not the case worldwide. And actually still kind of 6-7% of the global population lives in a coverage gap. That's about 500 million people. It's highest in Africa, proportionate to the population, which is why you see that sort of spike in the line graph above Africa. But it is still a material percentage in other regions. And what that means is that there are a lot of people that would benefit from this service who do not have access to it now. And I think a lot of the mobile operators operating in these regions want to be able to realize that benefit. I mentioned roaming as well. I think we're seeing a number of interesting commercial strategies being promulgated or put in place that look to use ubiquitous geographic coverage, not just population, but geographic coverage as an enhancement to existing tariffs or to drive wholly new tariffs. And we're starting to see that being trialed by a number of operators. And I think we're going to see more of that because our data from surveys tells us that consumers are willing to pay for this type of service. We know that there is demand for that, and it's really how it's put into a compelling proposition. On the B2B side, which sometimes gets less talked about, but is equally interesting as a story here, there is a range of industries that using IoT devices or modules have demand for satellite connectivity. We think that's about 2 to 3 billion devices worldwide. And we think that adds up to a potential revenue run rate, that is a very material $10 billion per year by 2035. as a touch point, that's about a quarter of what the operators make from IoT right now. So it's nothing to be sniffed at. And I think the interesting point here is that you see demand from a range of sectors. Connected cars would perhaps be more front of mind, but you see it in utilities, you see it in oil and gas, precision agriculture, mining rigs, these types of areas where satellite is being deployed, and we're starting to see that use. And I think that partnership model, predominantly where the satellite partner is playing a wholesale connectivity role, with telcos owning the end customer relationship, we're probably going to see more of those. And I think we're going to see a beefing up of the distribution efforts to reach these types of customers, because again, we know our survey data tells us that there is enterprise demand for this. So all told, this is a material opportunity. We think satellite in general offers the telco sector and its partners an uplift of $30 to $35 billion per year by 2035. About 2/3 of that is in the consumer, 1/3 enterprise, but that's material. And we're going to follow it closely. But that leads me to transition into the next speaker. I hope that's given a good flavor. And I am going to hand over right here. So Chris.
Thanks, Tim. So hello to everybody. We've got the next section really is going to be looking at how we as Mavenir played into that opportunity that Tim has outlined, and expand on it a little bit from our perspective, particularly in the context of the mobile network operator, which we hitherto and continue to service. I'll then be handing off to Suman, who heads up our product capability in NTN. And then we're going to be working with Jacques here on the call. He will go through the live example of his Terrestar network, and if you will, the manifestation of a lot of the concepts that Tim has alluded to, and we will amplify a little further in this section. So in entering the market, we had to, it's not a greenfield site. It's not purely about 5G. So in Mavenir coming into the space, we had to evaluate the space in total and to look at the opportunities that were emerging. We had to consider supporting the existing satellite services as they stood today, looking at NB-IoT for Industry 4.0 verticals, but also how they interworked with the MNO, particularly in the context of the potential switch off of 2.5G networks for things like meter monitoring, with the evolution towards direct-to-device for 5G with MNO partners in a richer sense. And ultimately, we saw that NTN can become part of the MNO network plan. So given that as a backdrop, we believe that the drivers, and again, looking at the gaps that Tim was talking about, we believe that one of the gaps in all of this is actually coming from the mobile network operator itself. They are challenged in terms of the pressure that's been on their business right really from the beginning in terms of their overall business case. And can 5G play a role in that? Not just in terms of servicing the remote rural edge, but also what we defined as the economic fringe, the point where it ceases to be viable to necessarily roll out 5G services, but could be affordable from a satellite perspective via NTN direct-to-device. The other element in this is the broader case as well, which is that curing of maybe the broader element of the business case addressed towards 2.5G services and the ability to be able to provide NB into providing the service into large enough swathes of territory, then facilitating maybe switch offs of 2.5G services within the MNO. So the consequential cost saving from an MNO perspective we saw as being fundamentally important as a business driver for the adoption of NTN. In support of that, the regulatory bodies have started to move towards ruling to support interworking with MNO partners, as we've seen with T-Mobile and Starlink and others around the globe. But in return for that, they are mandating that by a certain point in time, not spots will no longer be permitted. So with that architecture and that topology, you're moving to a position where coverage is going to be seen to be ubiquitous in one way, shape, form, or another, even if it isn't quite the same in the context of cellular and satellite. And I think the other primary driver is, again, I think Tim touched on it from an enterprise perspective, but from the 4.0 verticals that are out there in the market that have a need for connectivity, whether that be with mining, agriculture, power generation, or others, their need is only enhancing, and satellite has only but an opportunity to be able to connect and service. So in terms of the market data that supports all of that, they're big numbers. And I've got no idea whether these numbers are going to be absolutely correct or not. But I think the direction of travel indicates that the growth in MB is undoubted. The growth in NR and the revenues sustaining from NR, based on the data points that Tim's presented and also those in front of us now, are undoubted. The absolute number we'll find out over time. I think the interesting thing is, there's a general trend in the satellite sector which is making it more viable in terms of the cost to be able to provide and sustain the service. And I think there's another element to this, which is moving from maybe some of the more traditional geo services into the context of NB and NR direct to device. We're seeing a tapering off in some of the revenues from some of the geos as a consequence of people like Starlink taking some of that market from them. So it's a driver, a facilitator, if you will, for the necessary launch of some of their MB proposition. So with that as a backdrop, when we looked at how we were going to address the market, we made the decision that we were going to offer the full stack for both core and for RAN, both from a 2.5G perspective, certainly in the context of core, right the way through to 5G and release 17 and beyond. So we were going to facilitate some of that legacy market requirement, whilst we supported the evolution of MB, as we moved towards the development with people like Jacques of NR capability in the market. And actually that also, we quickly learned, meant that we had to embrace some of the thinking and financial aspects of both what was potentially going to be in release 18 and release 19, especially around aspects such as Doppler handling and regenerative and partially regenerative payloads. So given with that capability, we took that to market, and we've been working with satellite operators around the globe to develop the support of their business. But whilst we were doing that, in that process, it became very evident that we probably needed to do more than that. So being the technology provider, supporting that backdrop of the market, as I've defined, we also started to see that the market was requiring some form of design authority, because at the moment it tends to be in no particular order. The satellite operator will need to talk to the ground segment provider, then the satellite provider, and the back again. And that process in itself stretches the time to market launch by an exponential factor that the likes of Starlink and others don't suffer. We felt that if we could have a design authority position which embraced both the ground segment and the satellite and the operator wants, we could blueprint what a transparent mode would look like, what a partially regenerative mode would be, or regenerative, enabling the operator to build on top of those baselines at will if they choose to, but also it would give them a valid starting point if they didn't want to do anything else, why is that important? It's important. All of this is important in the context of cost. We've chosen to follow a 3G route that we probably will start to enhance as we go forwards, but it was very much with an awareness that the costs of the past have killed some of these propositions, and they couldn't do that again today. In order for it to be viable, there was a requirement in order to embrace the standard, to have standardization across multiple platforms in order to be able to bring those economies of scale to the market itself. So in terms of active deployments, we have NB that we can publicly announce at least. We have NB implemented with Legato in the US. It was our first deployment of NB and has been demonstrated to the market as such. With Terrestar, it's a slightly more ambitious program, as Jacques will outline as we go through that in a minute. It is looking at both MB and then moving up to especially as the satellite constellation evolves for NTN. But along the way, he's also launching innovation in things like voice over MB, which we intend to do during the course of 2025. So there's new revenue opportunities within the proposition that he's taking to the market, as well as providing a bedrock for the market that we've defined to date around the key elements of NB-IoT. And then in terms of our standing in the market, what we've done is we've evolved our relationships with obviously the GSMA here, with 3GPP. We are lobbying for release 19 and 20 and are actively involved with that, as well as working with groups like the MSSA. I mean, it says here that the MSSA was anchored by Viasat, but it's actually been driven to a large extent by Jacques and his team in terms of the innovation they've brought to the thought processes that surround it, and the efficiencies that come from working as a group as they are, building on what I've just been saying about 3GPP and the economies of an approach, and embracing the market opportunity to be able to take it to some of the larger operators that have already got the head start in that space. Suman.
Thanks, Chris. So I'll go a little bit on the deep on the technical aspect of the architecture, and then we'll talk about the 3GPP standards and go into the Mavenir roadmap that we are planning in the next 3 to 4 years. So the different network types, we're talking about geostationary orbit and non-geostationary orbit. When it comes to the geostationary orbit, we have geosatellites, which are technically not moving compared to Earth's orbit, and they are at the distance of around 35,000 kilometers. And MEO is at 7,000 to 20,000 kilometers, and LEO is at 600 to 1,500 kilometers. Those satellites will have different footprint on the ground. Geosatellites on the highest orbit will have each beam covering close to 200 to 2,000 kilometers in diameter, versus non-geos, those are around 100 to 500 kilometers for LEO and MEO satellites for every single beam. Now, those satellites are connected through the ground-based station, through feeder link, and through the service link, they're connected to the satellite phones. And from the satellite gateway, it is DU, RAN, core, and connected to the internet side. All the different applications that are coming into the picture are like IoT, remote connectivity, rural connectivity, urban connectivities as well. One of the key information that is also important is in terms of latency. So for LEO satellites, we're talking about 30 to 50 milliseconds of latency compared to MEO at 150 to 300 and GEO at 600 milliseconds round trip delay. LEOs compared to MEO and GEO will include increase in handoff, because the time on the ground that you are able to see a LEO satellite is close to 5 to 10 minutes, so between 60 degrees latitude. So there will be an expectation that LEO will have to make a lot of handovers depending upon the number of satellites that are visible at any given point of time. This is the NRNT and RAN architecture. So what we have done is like combine transparent payload and regenerative payload in a single view to make it more simpler. So toward the left side, you will see on the highest orbit a geosatellite with transparent payload. So it is not doing any kind of data processing, but rather taking the signal from the ground station through the feeder link, amplifying it, and sending it out to the NB-IoT UEs or 5G NTN UEs through the service link directly. When it comes toward the center, that's where LEO and MEO satellites are coming into the picture, into the regenerative payload as well, where we are putting entire RAN or partial RAN or some part of the core as well. So L1, L2, L3 processing as per 3GPP protocols, and part of core like UPF, AMF can also be sitting right on the satellite with silicon on board. Now, since these LEOs and MEO are traveling pretty fast compared to the Earth orbit, they have to be connected to the ground station consistently. And that's where we have the ISL link between those two satellites so that we don't have to build those many number of ground stations on the terrestrial field. So just one satellite will be connected to the gateway, and through ISL link, the rest of the satellite will be transferring the either backhaul or midhaul, depending upon what portion of the RAN network is going to be sitting on the satellite. On the ground, we have ground-based beamformer, which will be performing the functionalities like Doppler collection, multiplexing, demultiplexing, sampling, desampling, and after that, it will be connected to the RAN network through a digital interface. Now that standard 3GPP standard would be more like, eCPRI based, or have split 7.2, split 8.0 if we're talking about ORAN in that case. And then some of the operators, if they have not moved forward with the 3GPP standard already, they are slowly going to have it, or they will have it in the roadmap as well. So at that point of time, we will be having some kind of additional hardware for proprietary interface so that we're able to convert digital to analog conversion. Or in case they have analog interface at the ground-based beamformer, we can have the IF frequency generator to mitigate any kind of requirement on the analog port as well. So those are like a step forward toward the standards when it is toward the digital interface going on eCPRI basis. Toward the right is Mavenir RAN, where our G-Node B, the DU and CU functionalities are sitting on the COTS X86. So lo-fi, hi-fi, MAC, RLC, all those different protocols are going to be handled on the RU side, on the DU side. In regenerative case, most or some part of these protocols will be sitting on the satellite itself. This entire network can be hosted on the public cloud, private cloud, or hybrid cloud as well. Toward the right, you see is where the entire RAN is connected to the MCMS and XA. MCMS is the element management, which is taking care of all the alarm monitoring, locking and unlocking the sector IDs of particular beam, changing parameters, bringing a new sector, bringing a new beam transmission into the picture. And XA is our performance monitoring tool to ensure that the KPIs are monitored and you are able to identify the full performance of the network overall. And at the bottom, you see is the connectivity toward the 4G and 5G core, and then toward the application. Some of the key information that is also to take away from here is that Mavenir being a pioneer in ORAN technology, it will have a natural adaptation for us when it comes to regenerative payload. Some of the benefit of ORAN that will be applied on NTNR disaggregation of the network element. And their benefit includes like fitting with regenerative payload architecture, like, there could be inter-vendor operability. Part of the RAN can be sitting on the satellite handled by one vendor. Part of the RAN can sit on the ground station handled by another vendor. Other part can be sitting in the cloud, and the core can be another one. So that inter-vendor operability is going to be huge. And this includes, any kind of vendor locking, and can be really beneficial in the NTN domain. And the third very important part is the radio intelligent controller, the RIC, that can work through TN and NTN interworking as we move toward the release 19 features. NTN and 3GPP roadmap. So we have seen a transformation of features right from release 17, which was released in 2020, and it had features right from NB-IoT, NR on transparent payload, going toward release 18, 19, mostly having further enhancement in both NB-IoT and NR NTN, and toward release in 20 and 21 when we are moving toward the 5G Advanced and 6G features. Coming back on release 17, this is mostly for S and L band on the service link with transparent payload. Some of the major features are like timing advance, HARC over target distances, satellite location information, and we are also adding some of the additional feature on NRNTN like beam hopping, beam measurement, and stuff like that. When it comes to release 18, there are a couple of major features that is coming into the picture, which is support of FR2, FR3 frequency, which is greater than 10 gigahertz bands, and the support of bandwidth over 50 megahertz to up to 400 megahertz single carrier, single beam transmission. So those are the features that are coming into release 18, and the support is going to be for FR2 and FR3 frequency. Some of the additional feature will be Doppler correction, improvement on the LEO and MEO satellites, and further enhancement in the mobility, discontinuous coverage, and stuff like that. Release 19 is where the regenerative payload is going to be coming into the picture with store and forward architecture and further enhancement. Additional 5G feature that will be coming into the picture will be network slicing, 5G reduced capacity device support, and that's when release 20 and 21 where we move toward further TN and NTN interoperability, where we will have not just idle mode selection between TN and NTN, but dedicated mode handover also between the terrestrial network and non-terrestrial network. And that's our target around 2026 to 2027 timeframe. This is our high-level product roadmap for Mavenir. So on the left side, what you see is release 17, 18, and 19. And toward right is the list of different products that we are working on with the timeline on the top. So within release 17, NB-IoT NTN, we have that over-the-shelf product for GEO satellite already available. Only modification we have to do would be in terms of interfaces based on different customers, or if it is standard-based, we just follow right-away deployment. Toward right of it is voice over NB-IoT, which is one of the features that we are developing for Terrestar. Just imagine, NB-IoT or NRNTN, you can have data access. But imagine if you are in outskirts or in an ocean or somewhere where you don't have the terrestrial coverage and you're able to make a voice call over there. So that will be a huge benefit on the NTN domain to provide voice services. And after that, our target is to make sure that by end of 2025, we are able to deliver that. The first demo will be coming out around March timeframe next year. When it comes to NB-IoT NTN on LEO and MEO, our target is Q4 of 2026. And NRNTN on GEO satellite, we are targeting to deliver the product by end of 2025 timeframe, which will be EC3 compliance based, and that will be available around Q3 to Q4 timeframe next year. NRNTN on MEO and LEO will have the similar timeline as that of NB-IoT NTN LEO MEO. So our target is to make it available around Q4 of 2026 timeframe. Release 18, we are developing 3 major features over there. First is support of FR3, support of bandwidth up to 400 megahertz channel, and interoperability between LEO, GEO, and MEO satellite for customers who have all the satellites in their arsenal. So the target is to make sure that we are supporting the FR3 frequency by mid-2026 timeframe, and the bandwidth and interoperability around Q4 of 2026 timeframe. Release 19 is regenerative payload. That's where it is going to be driven by the 3GPP standards, and the target is to have the product available by Q4 2026 to 2027 timeframe, when the chipset vendors on the device ecosystem side is also adapting toward it as well. There will be an early regenerative or partial regenerative that Chris mentioned earlier that will be around 2025 to 2026 timeframe, where some of the satellite vendors will have some FPG on the satellite, which can take care of RF layer 1, layer 2 functionalities, and we should be able to develop the solution in terms of partial regenerative for them with different kind of split, like split 6.0, even 7.2. So Mavenir's regenerative view are basically twofold. Standard-based solution, which is 3GPP standard 2026-2027 timeframe, and this solution where we will be developing the regenerative RAN and core on LEO and MEO satellite with band support of L, S, and FR2 frequencies. KUK band is still going to be there on the feeder link side. There won't be any interdependencies on MNO partnership for service launch. Just because any satellite service provider should be able to launch their own network. There won't be any kind of dependency required on the MNO because of the standards supporting those different bands and the regenerative payload architecture. This will also provide global coverage, global services similar to any terrestrial MNOs, and having those kind of roaming partnership as well that will be coming into the picture with that. And chipset vendors are going to be aligned toward it as well. So that is standard-based solution. What is non-standard-based or the proprietary solution is actually going to be a partial regenerative or pre-regenerative that is going to come into the picture. The way we see it is in two different approaches. Approach one is where we will be developing RAN and core regenerative architecture for LEO, supporting L and S band, and later on with release 18 FR2, FR3 frequencies. We have to go and develop the specs as well. So defining the proprietary specs with Mavenir and operator has to be done there as well. And we have to drive the chipset as well to go and support us around 2025 to 2026 timeframe on this partial regenerative approach with some proprietary specs. Approach two is where we can use the existing MNO frequency in different terrestrial networks. So let's say one MNO is transmitting certain frequency for a particular geographical area. We will be transmitting the similar same band in other areas that are owned by that MNO, but they don't have the macro deployment over there. So a collaboration of MNOs to secure the band and controlling the RF interference is going to be the biggest challenge because the satellites are moving pretty fast and we have to ensure that they're not interfering with the areas where there are terrestrial deployment as well. So several features in terms of interference improvement will be coming into the picture. The best part about it is that it can leverage the existing ecosystem of devices provided they have NTN capability and it will be easy to implement. So these are the three different approaches that we are currently working on when it comes to the regenerative implementation. And the target is between 2025 to 2027 is when we'll be working on all these different features. From here, I'll hand it over to Jack to talk about Canadian market.
Yeah, thank you, Suman. Hi, everybody. First, it's a pleasure for TSI to be here today and express a little bit of where we came from, our visions, and where we're going. With regard to where we came from, I mean, we're a group of people who have been working into the cellular environment for many years. We were the one who built Fido in Canada back in '95. And then we decided to move from the concept of where we would Fido offer, service at a fair price or where we really make it affordable to all. And today we want to make it, available everywhere in Canada. So this is the visions that we had back then. We have worked over the I would say the last 10 years, really, to make these visions of reaching an everyday device, which we had proved with RGO, this capability back in 11, but unfortunately, the cellular ecosystem evolved at such a fast pace that it was impossible to follow it. So that's when we decided that we should have our band plan integrated into the cellular ecosystem. We should leverage the cellular ecosystem to make the satellite connectivity just as an extension, or I used to call it a flying base station. So essentially a base station's integrated into the MNO infrastructure, so it's just another access point. So that's what we did, having our terrestrial band plan integrated into the cellular ecosystem. We have 40 megahertz of S-band spectrum in Canada. This spectrum can be used both terrestrially and for satellite. So we were able to leverage our terrestrial network to support the development and investment into, I would say, the NTN service, and that's what we're doing. We have acquired, all the partnerships with EchoStar in the U.S. To have all this T1 satellite to provide service into the Canadian market. We have launched service in 2020 using, this proprietary technology. And in 2022, we moved to, the release 17 of the 3GPP, working with Mavenir to insert into our infrastructure on the ground, 4G, NB-IoT base stations and core network, which allow us as well to make some tests. We also incorporate, other party base stations that allow us as well, to test NB-IoT. And we are getting ready, for 5G direct-to-device launch service from our GEO satellite in 2025. As the Mavenir people have expressed, they will have, the ability to support us in having even a voice service with NB-IoT in 2025, which will make a big differentiator for many people. And we're also working right now with other Canadian vendors and partners around the globe to provide a global LEO constellation. We anticipate that we will start with one that will cover all Canada and move, interconnecting with a standard LEO constellations that will allow us, to have a global connectivity. It's important to understand that our visions of connecting everyone, everywhere to everything is a challenge in Canada. Obviously, we have about 75% of the landmass that lack, wireless coverage. It's about 14,000 kilometers of major roadway and highway that are not covered by wireless. So Canada has a very distinctive, I would say, geography, whereby within about 150 kilometers from the border, you got about probably 90% of the population residing there. But a lot of people have cottage, a lot of people go further north into the natures where there's no connectivity. And if we look at the Northern Territory, I mean, it's even worse. I mean, there's no fiber going there, so everything has to be carried through satellite. And so the First Nations community are also suffering a lot from having the same service as we have further down south. So the way we look at it is that we really want to, move and integrate, the NTN service with the S-band using, our satellite gateway here and interconnecting with the mobile network operator using all the Mavenir equipment in an open network. So the view is that we really want to be an extension of the cellular network. So that's why we're looking as, our satellite to be just additional base stations into the MNO network, which will allow them, to control all and over to, provisions the customer. So it's really the visions and the model we have. So that will keep the competitive arena at a fair place where everybody will have access to the service. And having, partnerships on S&L band around the globe, this under the same constellations or under a regroupments of constellations that will assure a customer with service wherever they go on the planet. The view that we have is essentially, to bring this connectivity to a smartphone. There's new smartphone coming to the market. Google, Samsung have announced NB-IoT device with chipset that will support NB-IoT. There's already, the Apple device that use it with Globalstar constellations, and we expect that they will also be supportive on other constellation as well. The service will be SMS chat. This is already what we offer, and we offer voice with the, I would say, proprietary device. And next year we will have, voice provided under NB-IoT device. We're also working with sleeve that could be essentially interconnect with legacy device that will provide the features that are coming into the new device, and that will be offering capability to address the entire subscriber base of the MNO. This will also be very attractive for all the IoT connectivity. We've already have connected numerous NB-IoT device through our existing GEO satellite. There's also NB-IoT cellular, box that support both cellular and satellite that are available and are coming to our network right now. And there's obviously, as we have seen from Tim, there's a lot of market opportunity into this sector. It's important to understand that, all this industry, from our perspective, we've been into that business for about 15 years right now with, aiming to offer direct-to-device to mass market and NB-IoT, throughout the Canadian market. Though, the standardizations and working all together was a challenge. So it's very interesting to see that today all these things is happening. But the other factor also that is quite important is that we are today at the crossroad whereby, putting more infrastructure on the ground from the MNO is not economic. And we have seen that in many countries, people or governments are subsidizing, the MNO to provide, I will say, equal service to all and have them extend their network. But as an example, just in Quebec, surveys being done to cover all the paved roads that are not covered by wireless will cost about $2 billion. And so with that money, we could build constellations and offer service throughout Canada, Europe, Argentina, New Zealand. So that's where we see, that this crossroad is happening right now. And we have seen that already, that launch vehicle and satellite costs have reduced dramatically. So this is what make it all possible today. If we look at what we call our key success factor here at Terrestar, obviously we're working with standardized ecosystem, the 3GPP standard, the GSMA, MSSA, and I will touch a little bit later on MSSA. But this is something that we pioneers and with, SNL band partnership, that we bring that together to be the bridge in between what used to be the proprietary satellite environments with the standardized cellular ecosystem, and making sure that, we will be able to interconnect the two in a standard way, which obviously will bring costs down, will bring service, up, and at the same time will allow to compete in a very efficient way to support similar service that we have, with cellular. Obviously, in the same way as our cellular evolved, from a simple voice to then, voice and SMS, and then with smartphone, with the internet, we'll see the same, coming from the satellite. We have seen, the Mavenir people talking about, NB-IoT, SMS, seeing voice coming, in 2025. So that path of evolutions will come pretty fast, on the satellite, having these integrations with the cellular ecosystem. The other benefit, which is part of our success, is that we have MSS S-band spectrum, 40 megahertz throughout Canada, which is a dedicated spectrum for satellite. And this really, is very helpful to support the evolution of service. We're talking about, NB-IoT, already looking at 5G NR to incorporate on the GEO that will also be used on the LEO infrastructures with all the release to come at the 3GPP. We've seen now more partnerships established with device chipset, infrastructures on the ground, satellite manufacturer that are coming into the game at reasonable cost, changing their way of building satellite, obviously influenced by what has been done at Starlink. So all that is in the best interest of all. This also required some government support to start with, the initial launch constellations, the GEO license to allow, LEO service under the same spectrum. It's an important aspect. And the other aspect that we are seeing more and more, and we are seeing it in Europe as well, the sovereignty of the country. Right now, all the spectrum and all the MNOs are governed, by local authority. In Canada, it's ISED. In the US, it's the FCC. And, people want to make sure that, calls being done on their territory will land in their territory, and they will have the ability, to serve what we call, safety line 911 here in Canada. And at the same time, being able to do lawful intercepts as need be. And it's important for all country. And we're seeing that in Europe right now, where they look at getting, the industry together to make sure that they will have, the infrastructures. And on the MNO side, and I will say also from the regulator, they want to make sure that there will be fair competitions. Nobody wants to be dependent on one or two, let's say, satellite operator that will dictate the environment. So it's important to have that type of sovereignty and that type of competitions established in each market. The other factor is strong financial. Obviously, we have seen the first company launch their service coming from very strong financial backers. So it's the same. I mean, the Terrestar has the opportunity with the very smart regulation that was established in Canada, and the fact that we're able to have our terrestrial network, I will say, incorporate into the cellular ecosystems. It's allow us today to sublease our terrestrial spectrums and have a cash flow and being EBITDA positive that allow us to reinvest all that cash flow into the development of the satellite business. The MSSA has been eluded. It's an important, group that formed that, and there's more and more partners coming into the MSSA. Essentially, the mindset of the MSSA was to keep the end user at the center of our goal, and our way of looking at it is not to get around the MNO, but make it our service as an extension of the MNO, as I explained. And when we look at the value chain, it's important that all piece of the value chain being part of the MSSA contributes to, I would say, a standardized way of doing things and ease the interconnections and ease, I will say, the availability of the different components from a satellite manufacturer through the infrastructures on the ground and core network. And we have seen Mavenirs that are pioneers into that and are offering, these new ground infrastructures that will allow, to interconnect cellular, satellite all together to the benefit of MNO and end user. All the end user application service platform also is important to be interconnected. The user equipments and components, and obviously the spectrum, which is key. And having SNL spectrum at the 3GPP and having a bunch of partners working together, this already been a success and is getting large attractions. The MSSA have made, partnerships with GSMA which is very important, and there's more to come. So it will be an important, I will say, standardized groups that will make end-to-end scalable, sustainable, affordable to anytime, anywhere. So this is really the missions of the MSSA, to foster innovations and evolutions of satellite to terrestrial mobile telecommunications. Then I talk a little bit about this ecosystem. It's really to unlock the direct to mobile. This is the mass market. It's billions of users around the globe. Everybody have experience, within, I will say, coverage, all or gap of coverage. We've all experienced, getting outside of cellular network for weekend vacations, hunting, fishing, or even going through one city to the other, and we lack coverage. So this will be possible today, as I said, with all the different components of the ecosystem to make it happen. In conclusion, if we look at Terrestar, we're the only Canadian MSS operator in this space. All the other ones are foreign company. We have the operational and financial capability to make it happen and make it a success. Our LEO roadmap will cover all Canada. Our roadmap respects the Canadian sovereignty, and Terrestar will be an extension of the cellular network. This is our positioning, and this is how we want to address the entire market. So it's important to understand, and Tim have expressed, the different player into this environment. And what we've seen thus far is a lot of people talking about Starlink, AST, Link, the Kuiper constellations. Nobody talked much about, the geo-licensee. People feel that the geo-licensee are out of race, but it's misleading. I think that people have to understand that spectrum is key in this environment. The geo operator already have a base of subscribers. They already serve people. They have this opportunity to enter into this, I will say, standardized ecosystem. The regulator are favorable, to support these competitions, allowing, the geo licensee to use LEO constellations to support the service. And there is a lot of opportunity for all of us, to combine the constellations to the benefit of all. And this is what we're doing right now. And we're serious about it. And obviously in 2025, you will see news announcing new constellations coming from S or L or S and L licensee, which will favor, this entire NTN industry and the different, I will say, party involved into this value chain. So on that, I thank you all. I think that it will be time for us to go to questions and coming from the panel. So on that, I'll bring the floor to the Q&A.
Well, thank you, Jacques, and Tim, Chris, and Suman for a fascinating conversation. We have time for a few very short questions. I'm going to put you all individually on the spot, and it's a speed round. Suman, I think coming to you first. We've got a question. It's looking at the availability of space-grade radiant devices. Somebody says it's become a big concern for the regenerative payloads. How do you think the industry should come together to solve that? And how should big players like NVIDIA, AMD, Intel be aligned on sort of providing more resources per gigahertz?
Yeah, thanks, Mike. That's a very interesting question. So SWAP is the size, weight, and power component of the satellite when we are going toward the regenerative payload. So in my opinion, more than size and weight, I think the concern is going to be on the power issue. So as we know, like RF, DU, CU, and part of core like AMF, UPF on board will derive more power than transparent payload, which is not doing any data processing, but actually just amplifying the signal and mostly taking care of the RF part of the network. One thing to note would be that in the entire telecom network, RAN consumes about 70% of the total network power. And out of this 70%, almost like 65% to 97% of the power is being consumed by the radio itself, depending upon the traffic it is serving. What that means is remaining 35 to 3%, depending upon the traffic, is being consumed by DU and CU. So that proportion is smaller. So there is going to be increase in power, but that is not going to be very significant as we are expecting. But there has to be silicon on board development that will be required, which has to be space optimized, power efficient chips that will be focusing on maximizing the overall resource processing per gigahertz per watt that was mentioned. So that is definitely required, but the impact is not going to be that major. Back to you, Mike.
Thank you. I think we're going to select Jacques next. Will it be possible to offer the same current end user price in the case of in-country roaming over satellite direct-to-device?
Well, this will certainly depend. As we said, I think the model that we have in mind is essentially, to kind of wholesale our service to, I will say, local MNO. So we could expect that the MNO will provide additional value to the end user. And of course, I mean, we've seen that today in the environments with the initial, I will say, service coming from the Apple device, where people see the value in it. And I've experienced it myself with friends during, I will say, out of cellular activity. When I show them how to use it, I mean, everybody said, okay, I'm going to go buy one, So you see the notion, and we've seen that even in our regular day. I mean, we leave our phone back home or in the office and we go back get it. It's our lifeline. I mean, we cannot go anywhere without it. So there's a value to be connected and to be connected everywhere. So I think that within the, let's say, Canadian market, we will certainly offer the MNO the opportunity to have, I would say, kind of an extension of their network at a price that they will decide, either bundle it into their high value package, or they will offer it as, an extensions value for their subscriber. Being part of a global, it's the same way as what they're doing on terrestrial today, meaning that, Canadian subscribers going, let's say, to Europe will then roam, outside of cellular coverage, on the satellite. And that should be about the same type of pricing that they're seeing today. So it's just a question of, I will say, timing. Obviously, any new product that come to market have a tendency to be higher at the beginning. And as it's evolve and more people use it, cost structure go down, and it's allow, the opportunity to reduce the price and have everybody benefit of it. So that will be, I will say, my 2 cents judgment at this time.
Well, thanks, Jacques. I'm actually going to stick with you and keep the spotlight there. Have you any plans to work on offloading to 5G broadcast operators?
Well, it's difficult. I will say that today, when we talk about video and stuff like that, when we look at the roadmap that Mavenir have showed up, I think that satellite today, it's still at its infancy stage in terms of service availability, and we will see that evolve. We have discussions with different parties, and I do expect that this kind of a team video or, looking at something on the web will be possible. I mean, that is no doubt in my mind, okay? Would it be possible in the next 2-3 years? I will say no, okay? I think that we will see that evolve. Obviously, there is different ways, because in the satellite space, it's like on the ground. I mean, you have really 2 categories. You have, I will say, what I call the fixed environments, and you have the mobile environment. Okay, on the fixed environment, we've seen that today's satellite fiber can really provide you a good internet connectivity, and you could stream video, you could watch TV on it. I mean, it's not an issue. Okay, it's big power supply at both ends, that allow that. On the mobile side, given, I will say, the restricted power and the small device, then it make it more complicated. But we have seen that evolve. I mean, back in 95, as I said, when we launched the cellular company, voice was only the product. Then it evolved. I think the first thing we'll see more and more will be what consumer like the most. So having, let's say, the opportunity to use something that will guide you on the road, like, Waze systems, Google Maps, stuff like that we will see. But I don't think we'll watch an hockey game in the next few years on a satellite with our mobile device.
Thanks, Jacques. Suman, back to you. Just to very quickly tell us about security and data privacy. Obviously, this is going to span multiple countries. So how do you meet those in-country sort of requirements everywhere?
Yeah, no, security is going to be a challenge because, we are talking, and mostly when we are talking about LEOs and MEOs, because those satellites are going to be covering the global terrestrial areas. So a couple of things that comes to my mind is, of course, fencing. So geofencing and the data localization for the storage of the data, that will be very important to ensure that you're not actually putting the data storage all across the different terrestrial areas. And edge computing nodes location has to be restricted as well. So geofencing, data localization of data, and then edge computing nodes restricted in location. And secondly, the compliance with the country-specific standards and policies that Jack also earlier mentioned. So that compliance with different country with their own standard and policies for the security has to be taken care of.
Thanks. Chris, I'm going to very quickly come to you, and then we are very tight on time. So I might combine a couple of these questions because they are interesting. Is satellite a viable solution for most connectivity projects in terms of cost?
Can be. It's a big question. I think it really depends on, as the guys have said in the presentation, it depends on multiple factors. It depends on the consumer enterprise demand, depends on the alternative routes, and also the consequential cost saving maybe on the part of the network operator to utilize satellite to be able to do that. But the viability is there, providing that equilibrium holds.
Thanks. And I think we'll maybe just end with one more for all of you, whoever wants to pitch in, because it's relevant. Will a user device need line of sight? So, will it need line of sight for the direct device to actually function?
I think that's one for Suman.
Yeah.
Very bold.
Well, I will tell you from my perspective, I think that line of sight at the beginning is required. And, this is because of the device, okay? The satellites see the ground, see everything, okay? And then the device has to evolve. The antenna on the device need to evolve. Right now, we're testing it on our side, with different antenna, and that's improved the service dramatically, okay? So it's just an ecosystem that will evolve. The good news is the race has started, okay? It's not that we're looking at something to happen. It's happening, okay? The device race have started when Apple have launched a few years ago the SOS service. This year, we've seen announcements of other device manufacturers saying they will offer SOS service. Right after that, Apple announced that they will offer SMS service, okay? Mm-hmm. So all that have started, even the Apple today, the future is that you need to point to the satellite. So there's an education going on showing that. The other factor is that taking, for example, the car industry. Already the car industry is working on a different antenna to put on the top of the car that will be more omni antenna that will be able to look around and connect with the satellite, in movement. So it's all the different, I will say, elements into the value chains that are evolving, to make it happen. And given the fact that for the end user, it's important, and we're seeing that. Apple has invested hundreds and hundreds of $millions just to be first and show that, having an Apple device kind of provide you security. Okay, so it's a notions of security, and people are willing to pay for security. And that's why I believe that at the beginning, you will have to have a line of sight. When I say line of sight, it means that pointing at the satellite, but you could have obstructions in between, trees and stuff like that, and it works. So then the question will be, how do we make, these devices in a way that it could look at a satellite in a better way? And the other factor is, as more subscriber will use it, more capacity will be needed, more satellite will be up in the sky. So you can always have more than one satellite at view, which will at the same time ease, I will say, the connectivity to the small device. Okay, well, Jacques, thank you very much. And also Suman, Chris and Tim, it's been a fascinating discussion, but we are absolutely out of time. So it's a good place to wrap things up. Thank you also to our audience for tuning in and for those great questions. Apologies if we didn't get through them all, but a replay of the webinar will be available shortly afterwards. And of course, you can always contact the companies directly if you have any further questions or want some more insights. So I'll just say thank you once again to our panelists. Thank you all. Bye-bye.
Thanks, Michael.
Thank you.
And goodbye. Thanks for joining us.